So now let's move down to the bottom of our page, and we have 4 problems here. The instructions are to identify the transformation from figure A to figure B using reflections, rotations, translations, or non-rigid transformations. So let's take a look at these 4 problems. So problem number 1, we're going from figure A to figure B. So figure A is the pre-image, and figure B is the image. Okay, that's the case in all of them. So we're starting with this, and we're going to this. Do these both have the same shape and size? Are they both congruent? If so, we're dealing with a rigid transformation or an isometry. So it's not a non-rigid transformation. We know this has to be either reflection, rotation, or translation. Well, is there any reflection going on? Well, this driver is looking to the left side, right? This driver is looking to the left side. If we had a reflection, we'd expect that that would reverse the directions of things. So if this driver was looking to the left and this driver was looking to the right, that would suggest that there was some kind of reflection going on, but there isn't. The other question is there any rotation going on? Well, the road seems to be sort of like this, seems to be sort of horizontal, and the road here seems to be sort of horizontal. So there really hasn't been any rotation at all. The only thing left is translation. So this is a translation, and it's a pure translation. It's the only thing that is going on here. Now contrast that with problem number 2. Here we've got figure A is the pre-image, and figure B is the image. So we're going from this to this image. Well, clearly there's some translation here, right? We're actually moving from this location to this location. So there's some translation. I think you'll also notice that these are congruent figures. This is the same shape and size as this figure. So basically we do not have a non-rigid transformation. We only have rigid transformation. And therefore this has to be some combination of reflection, rotation, or translation. Well, we said already there's some translation here. But look now at the road. This road is sort of going in that direction, and this road is sort of going in that direction. So these lines are not parallel. This is sort of going down, and this is sort of going up. That implies that there is some rotation. There was some turning of the car at some point like that. Or actually, I should say we started with A, and then we translated it to B, and then we had to rotate it around like that. So we have an upsloping line there. So we clearly also have some rotation. Do we have any reflection here? Well, no, we don't. That's all. Translation plus rotation will be able to explain everything here. So that's what we've got in figure 2. Let's look at figure 3. Now here, figure A is the pre-image. Figure B is the image. So we're starting with figure A and then going to figure B. Well, are these both the same size and shape? They look about the same shape. You can tell that they're both racing car drivers within a racing car, but the size is not equal. So if the size is not equal, that means that the lengths are not equal. What I mean by that is, for example, look at the distance between the 2 hubs of the wheel here. That distance is about that long, and if we drew the same line segment here, for the corresponding points, we see the line is much smaller. The line segment is much smaller. Okay, so therefore we are not preserving length, we are not preserving size, and this is a non-rigid transformation. Okay, so the answer here with that, this would be a non-rigid transformation. But we actually know specifically what type of transformation it is because we had the vocabulary word. If the size is changed, but the shape is preserved, as in this case, we have a dilation. So that's what's going on here, is a dilation. And there may also be some translation as well. We can't be sure. We'll talk about dilations at another time, but you can see that there is, the figure went from this location to this location, so there could be translation in there as well. And finally, let's look at figure 4. We've got our pre-image, which is figure A, and then we've got our image, which is figure B, and these two figures are obviously congruent. So we've got we've got ourselves, at least they're congruent in 3 dimensions. You might actually notice they're not actually congruent in 2 dimensions. If I cut this one out, I probably couldn't put this on top of this one, okay? But if I flipped it over, I could, okay? So they are congruent, so we have an isometry, and and that's all we need to explain how we got from figure A to figure B. I can go ahead and I can draw in here a line of reflection. So let me put in the line of reflection over here. And you can see that it's almost as if the 2 cars are looking right at each other through a mirror. One is the mirror image of the other, and therefore we've got a reflection. Okay, so let's look at our questions here. Identify the pre-image and identify the image in each one of these. We've done that. Number 6, is the transformation in problem number 1 an isometry? Yes, we already talked about that. Question 7, is the transformation in problem number 3 an isometry? No. Length is not preserved. What is another name for number 3? We already said dilation. And so we are going to continue on in your workbook. So please have your workbook ready, Explorations in Core Math, and we'll continue with that in the next video.